see. So I just want to start by saying that a lot of people talk about serverless and as the same thing as function as a service, but for me that's not really true. I think function as a service, FaaS in short, is a really good first step. It was really groundbreaking when it came about, and it's really been showing the way, showing what's possible. But it's only the first step on a long journey towards this, nirvana, this amazing cloud experience that we all hope to get to one day. For me, so serverless is really all about an experience for developer, for operations, for deployment, that is completely new. In order the one that sort of removes as much as possible from the essence and moving it away to the runtime, to the back end. So you as a developer, or we as developers, can focus on only the essence. And what I would like in my sort of grand vision for the future of the cloud, I would like to build any type of application, build sort of general purpose application, full applications in this new experience. Function as a service is currently sort of tackling one subset of the use cases in a non-trivial application. Sometimes a large portion, sometimes a small portion, but it's just really hard to tackle, everything that we need in a non-trivial real world application in just function as a service. So we need something more. So the question is then, what is the missing piece? What is missing here? And I believe that it's state. It's good ways of working with state, solid models for abstracting over state, to essentially having good ways of abstracting over state so the runtime can manage it for us effectively. And so some of the technical requirements that I see that we need in such a sort of new way of writing any type of application in this new experience is first support for stateful, long-lived, addressable components that can be virtual as well. It means that you have stable references, stable addresses, but they can still move around, maintaining their data integrity in their state, while the address remains stable. So even if they're relocated, passivated, activated, you can still trust the reference talking to it, and don't need to worry if it fails and it's respawned, etc. We need a wider range of options of tools in the toolbox, so essentially for distributed coordination and communication. PubSub, like we have in Function as a Service, is great, but it's only one way of communicating. I believe we also need support for point-to-point, for broadcast, and for things like modeling orchestration of workflows, using things like sagas, process managers, etc. We also need options for managing distributed state reliably at scale, and not just having one size fits all. Not saying that everything needs to be strongly consistent or everything is eventually consistent, but having options ranging from strong to eventual through causal consistency. So you can fit serve the weakest model that gets the job done. Because if you add layers of safety, of guarantees on top that you actually don't need, that's wasteful. So you actually want the minimum guarantees that gets the job done, that liberates the runtime to do even more things in terms of scale and availability. Okay. We also want intelligent, adaptive placement of stateful functions, things like sharding, having a physical co-location of state and processing, as well as sticky routing. These are very important things in order to manage data at scale, performantly at scale. Function as a service is really good at abstracting over communication. So you have your user function and you have your sort of message in. You don't need to worry how it ended up there. It just it sort of ends up on your mailbox or on a queue to your function and passed into you for processing. And the same thing, message out. You only emit the event, and you don't need to worry about where it will end up, who's going to pick it up, etc., and the mechanics for doing so. You have well-defined interfaces for message in and message out, or event in and event out. And you just work towards those. But the problem is that sometimes you need to manage state. But if you talk to the database directly, you're sort of moving a lot of these operational concerns, the things that function as a service or serverless, rather I would say, is meant to manage for you. It's supposed to abstract away all these hard things, but by managing, so data access and usage from within your function yourself, you sort of eliminates that option from the table, essentially. And the problem is that now the function, is sort of a black box to the runtime. If the function manages state it's himself, the function can't sort of see in and understand what's really going on here. And it's a fact that sort of unconstrained database access, which sounds like a good thing, and more power is good, right? But it's actually not always the case, because it makes it really hard for the runtime to automate operations on behalf of the function. So it's really hard to understand sort of the intention of each access. For example, is the operation a read or is it a write? Can it be cached? Can consistency be relaxed, or is strong consistency always needed? Can operations proceed during partitions and failures, etc. Right? If the runtime understands these things, it can make intelligent sort of decisions more effectively. And also, see broadly across all of your entities and making things, collectively optimized. And as Timothy Keller, once said, that freedom is not so much the absence of restrictions as finding the right restrictions, the liberating restrictions. So the question is then, what are those liberating restrictions? And as I said, function service is really good at abstracting over communication. So you have message in and message out, as we just talked about. The question when we asked ourselves at Lightman was, is it possible to abstract over state in the same way that function as a service abstracts over communication? So instead of just message in and message out, you also have state in and state out. So it's sort of an inversion of control here. Instead of the function manages himself, the state gets passed to him, and he can just emit state. And all the sort of hard things around managing that, how the state is handled in the backend, is sort of delegated now to the runtime in a true serverless fashion. The problem is that CRUD doesn't always fit this model, but we need new models and new ways of thinking about the state. I'll get to that just in a second. So that was sort of the premise when we started Cloudstate, trying to answer the question: can we abstract over state in this way? Can we provide, a stateful addition to function as a service that's great for stateless workloads? So the joint thing can give us the platform we need for general purpose applications. So, what is Cloudstate? You can find out more after this talk if you go to cloudstate.io. But the overview is that first, it's open source, fully Apache 2. It's available on GitHub. You can just go and check it out and mess around with the code and contribute, ideally, if you like. The sort of short one sentence is really that it's distributed state management for the cloud in a serverless experience, as I talked about. And it's really two things. First, it's a reference implementation, but it's also standards or a protocol and a specification. So this is possible to create more than one implementation if people feel inclined. But the essence is that it lets you focus on your business logic, your data model, and your workflow. That's it, essentially, and how to configure declaratively these things. It's sort of leveraging Akka to do a lot of the heavy lifting, the cluster sharding and persistence and things like this across the nodes, the Kubernetes pods and things like that. All the hard things around state, both long-term durable state as well as like more short-term ephemeral state, coordination type of state, scratch data, and these things are managed by Akka. It leverages gRPC as a protocol between the backend and the client. I'll get to that just in a second. It leverages Canadian Kubernetes and also runs on Graal VM, which allows us to compile it down to native. Since Akka runs on the JVM, it's very important to minimize the memory overhead and the startup times. And Graal VM really helps us with that. So it's really polyglot. And here's where we sort of leverage gRPC. The gRPC sits right in between. It's a protocol how clients sort of make use of this sort of distributed state management, and essentially any language that has support for gRPC can be supported by Cloudstate, because essentially all these clients are gRPC clients, and we currently have support for JavaScript, TypeScript, Java, Go, Dart, Python, .NET, Rust, Swift, and Scala. Not all of them are complete, but a lot of them are being worked by the community as we speak. So it's really exciting to see the community pick these up and sort of cranking these client libraries out. It also supports like polystate. As I said, CRUD's not always the best answer to sort of the serverless state serverless story. But other models that I think fits better is that we support now in Cloudstate is event sourcing. I want the time to go through what that is really and how it works. But event sourcing is really, really cool. CRDTs, like it's essentially conflict-free replicated data types. It allows you to share state freely with the cluster without worrying about race conditions and inconsistent data. It's eventually consistent, while event sourcing is strongly consistent. So it gives you two models for that. We also have key values too. And it supports that across a wide range of databases, SQL, NoSQL, NewSQL, and also in memory replication. So if we're just going to end by sort of zooming out a little bit, what it looks like, is that you can see on the right hand side that that we can write functions or these entities or functions, stateful functions in any language. Like we can have, for example, a Python type of shopping cart. We can do Java implementation of an order, and we can have a JavaScript function implementing the inventory in this simple example. But the interesting thing is that for all the clients, web clients, IoT clients, they communicate over gRPC to these entities, but they do that through the Cloudstate proxy. And the Cloudstate proxy is sort of managing all the data on behalf of all these entities. It sort of populates them as needed, as they are requested, So all of these entities are always fully hot. They always have the latest data available. It's sort of truly really endpoints, and the database sits in front of it. Again, having this inversion of control, where each entity is just, sort of sent the things he needs at each moment, so to speak. And the Cloudstate proxy looks across all of these entities and optimizes the data storage for all of these state models across all the entities you have. So that's all I had as an intro. So now James is going to give us a little demo here.
So I'm going to be giving a demo of Cloudstate. I've prepared a UI for the backend that I'm going to be implementing, which is a conference Q&A application. So this is the UI here. We can go and select a presentation. We can ask a question, but nothing happens because the backend isn't yet implemented. If you want, you can actually visit this and start using it once I deploy the backend, csqa.app. Please don't ask any questions with naughty words in them because you might get into trouble. So I'm going to be implementing this in JavaScript. Cloudstate supports a wide range of languages, but JavaScript seems to be something that most people don't understand, so that's what I'm using today. I've done some preparation. I've got a Docker file here with my dependency on the Cloudstate support. My package JSON. I've got a Docker file here that will let me build a Docker image. And the first thing to look at is this protobuf file. So all Cloudstate services define an interface to accessing them using protobuf. So you can see here we have a service Q&A. We have two RPC methods, an ask method, which is going to be used both to ask questions as well as to vote on questions. So if you ask the same question twice, that counts as a 2 votes for that question. And then another method here, which is watch, and that returns a stream of questions. Now, Cloudstate So obviously supports gRPC streaming, but it also supports HTTP transcoding, and that stream will be streamed as an event-sourced stream. So these annotations here describe how it's exposed over HTTP, and that's what my browser will be using. So an important thing to see with these input messages, ask request and watch request, we go up here. Ask request has a presentation and a question. The presentation has this annotation on it saying that this field is the entity key, and that's how Cloudstate knows which the key of the state, in this case, that the ID of the presentation that you're talking to, so that it can make the state for this entity, for this presentation available. So similarly, the watch request also has that presentation with the entity key. So these will be routed to the right entity for that key. So let's go and actually implement this in JavaScript. So the first thing I'll do is I'll require the Cloudstate CRDT support. Now, I'm going to be, as Jonas mentioned, Cloudstate supports a number of different state models, event sourcing and CRDTs, two of those. So CRDTs are conflict-free replicated data types. They're designed to be able to be scaled greatly across many nodes. You can not only read them, but write to them concurrently across any nodes with no coordination. So you can do two concurrent writes. They don't need to be dependent. They don't need to happen one at a time. The CRDT will guarantee that those that the concurrent changes will be merged and in a deterministic fashion. So having imported that, I can now instantiate my CRDT entity. Here I'm referring to the protobuf file, Q&A.proto, and the service that I'm going to expose from that. And I'm then going to set a default value for my entity. So if my entity doesn't exist when the first request comes in for it, we're going to instantiate a new OR map, observed removed map, which is essentially a map structure that is a CRDT. So the next thing I'm going to do is I'm going to start implementing my ask request. So I write a function, ask, I take in the request message, and I take in a context, which lets me interact with my state. We've set the state to be for this question to be a G counter. So again, a G counter is a counter where you can increment it on many different nodes at once, and you're guaranteed that eventually when they all gossip the state change to each other, they'll all arrive at the same value. So, and then once we've ensured that the state is set, that the counter is set for that question, we then go and increment that counter by 1 to say that we've just voted on it, and we return an empty object because the ask function doesn't return anything. So now we're going to implement the watch method. So I'm going to write a couple of helper functions to help with this. The first is to copy the questions. So we take the OR map and we convert it to a JavaScript object. So for each question and counter, we'll copy it across and then return that map of questions. And so then in our watch function, we get our copy of the questions and then return it. So when we do this, that will be the first message that's sent down that stream is the initial set of questions. But we also want to see when we don't want the user to have to click refresh to see changes. So we want to respond to state changes. And so to do that, we set an on state change callback, and I'll create another helper function here called update and diff questions. So this will take that copy of the map as well as the current map and work out which questions have been updated. So going through each thing in the map, check if we have that question or if the counter value has changed. And if it has, we update it in both updated as well as our original map that tracks it, and then we return that. And so now we can get that updated questions map. If there's anything in it, then we'll send that down the stream. And so that's what our watch function looks like. And now we can register those two functions as command handlers for our service. These ask and watch need to match the ask and watch methods in our gRPC service here. And finally, we can start our entity. And that will start the user function. So I'm now going to build that Docker image. While that's happening, we can have a look here at the next thing that I'm going to do, which is to deploy this to my Kubernetes cluster. So this is a Cloudstate stateful service. It's pretty simple. We just say we have our Cloudstate Q&A image there, and that looks like it's built. So now we can do a kube control apply -f Q&A.yaml. And we should see a pod being created. Now there's only one node there. This is about stateful serverless. Since there's no load, it's not going to scale up for us right now. So I'm just going to scale that manually up to, let's go up to 6 replicas. And so we should be able to see here that that's now created 6, and that should begin scaling up. So now if we go back to our app and we refresh, we can ask a question, does this work? And we can see there, yes it does, and we can vote on that. And if other people go to this presentation who are watching along, we might see some other people interacting with it. Or if I open another window and go there, vote. Yep, we can see other people are starting to vote on things now. So that's happening in both windows. Feel free to ask more questions there. What you've seen now is how simple it is to implement these stateful entities. We didn't have to deploy a database. We didn't have to worry about setting up a cluster of nodes gossiping that state to each other. Cloudstate did it all for us. And that's everything that I had to talk about. Do we have time for questions?
Yeah, I think we have 10 minutes. So if you guys have any questions, please put it into the Hoover app, and then you can unmute yourself and ask a question. But whilst people are doing that, we're just playing around with the demo app. Maybe I've got a question or two as well. Because when it comes to serverless, one of the first things that at least I think about is using managed services and not having to run any infrastructure myself. So this looks amazing. This very different to the way that I've been used to writing applications and bring the state to the function. Makes life a whole lot easier. And the fact that you can just listen in on the entity updates without having to go through things like, database updates, and then you process the stream from the updates, and then you do something, write stuff back into the database. But do you guys plan to offer it as potentially like a managed service, something that you can, I can just deploy my code and you would be managing the, running the code and all of that for me, similar to how Lambda and other FaaS managed FaaS platforms do?
So yes, we're currently developing a managed service which should go into beta pretty soon. Obviously it's an open source project that you can deploy yourself to your own cluster, and so you could, for a large team of developers, you could have an operations team that just manages Cloudstate, and then they just deploy their functions. But yeah, if you want a cloud-based solution, we're going to be offering that pretty soon.
Well, I think one of the benefits from my perspective with serverless is obviously the kind of that you can cost it per function. So is there kind of any kind of effort to work maybe potentially with other cloud vendors to have this as you've already said that you're going to do it as a managed service, but yeah, to really kind of leverage that kind of pricing model, because I think that's the really powerful thing if you're not having to say manage the Kubernetes instance yourself, for instance.
Yeah, so when I say a managed service, I mean you'll pay per function. So we like then runs the Kubernetes. You don't even really see Kubernetes at all. You just deploy your services, and we charge you. Yeah, based on that. And
I guess when you say per function, you mean the per event that trigger that runs your function to do something, right?
The pricing model we're still working on. So whether it's very easy in a stateless world to do, because you can very easily cost a single invocation. In a stateful world, there's actually a lot more going on behind the scenes when things aren't being invoked. For example, you're actually holding that state somewhere. And so just working out the right pricing model to be able to fit in with a serverless model is something that we're still not 100% sure on, but we're working on. I do hope it will be a combination of, well, you're emitting these events, you're executing these functions, and you're persisting these things, and somehow we'll work out what that's going to cost in a way that benefits both the seller and the consumer.
Sounds good. What about just in terms of use cases? Because a lot of things that you're showing in terms of as a general purpose programming model, you can also do it with CRUD. You can also do it with other things. Using this may be better in some cases, but can you think of some, I guess, killer use cases that would be really difficult to do with stateless functions and the CRUD?
So, I mean, one of the things in a cloud environment, you're in a distributed environment, and you often need to say update a database and then send a message. And doing those atomically, especially in a cloud environment, is not usually feasible. So how do you manage that failure if one happens and the other doesn't? This is one thing where, say, using an event-sourced persistent model is really useful, because you have the event stream of events and they're high-level events that your application, and you can then disseminate those throughout your application with this very strong consistency guarantees that everything's going to work. That a failure mid transaction is not going to cause you a problem. So I think there's a lot of general purpose use cases where what a cloud state model does is simply offer you more resilience in the face of failure. And then with the CRDTs, well, these are very scalable to many nodes. You can, if you were like a counter like that, if you try to update it from 1 million nodes in a CRUD database, your bottleneck is going to be on that hotspot on that one row that you're writing to. No matter how scalable that database is, it's still one row that's been written to. Whereas offering CRDTs, you can scale virtually infinitely on updating one piece of data.
Yeah, I also remember there was a while back, there was quite a few attempts to bring CRDTs to the edge with things like, I think there was a company called Near Cloud. They did something quite interesting, so that you can do edge computing, but with CRDT, so side by side with your function code, so that you can update data locally, but you still be globally consistent eventually. So we've got one more question from someone from the app who's not able to unmute himself. So I'm going to ask the question on his stead. How does Cloudstate compare to other stateful, long-lived addressable actors like Orleans? how does Cloudstate support transactions like Orleans?
Okay, so when it comes to so Orleans is probably at the technology level that Cloudstate builds on, which is, so Cloudstate builds on Akka. Akka is an active framework. Orleans is an active framework. I think Cloudstate itself sits at a higher level than that, being a managed serverless solution that you can deploy things deploy things to. Jonas will probably be much better at answering the differences between Akka and Orleans. If you want to try and handle that, or Jonas is muted.
So I guess for my experience with Orleans, it's a virtual actor, so that the actor is not long-lived. They just disappear. So when you don't need them, and then they comes back online when you do need to ask for them again later. So I guess that's kind of quite similar to some of this. I guess the FaaS model where your function just gets scaled down to 0 when you don't need them, but then when you do need them, they just pop back up based on this on demand. Is that something?
Can you unmute Jonas, by the way? He's muted and he can't unmute himself.
Okay, I should be able to. Ask to unmute. Jonas. Try now.
Okay. Sorry, yeah, it's been frustrating to be muted for 15 minutes of Q&A. I tried all ways of getting people to recognize I need to be unmuted. But anyway, here I am. I think most of the things have already been said, but I think as James said, Akka and Orleans are similar beasts. This in Cloudstate, we're trying to raise the abstraction level on top of that and making more decisions and taking care of more things. Orleans has this interesting thing of providing virtual actors that are always there in a way. They're passivated on demand, activated on demand, and things like that. And Akka doesn't have that. And in a way, Cloudstate adds that model, and you can say through auto scaling and these things. So I think in that aspect, I think Cloudstate comes closer to this virtual model of Orleans, while Akka provides a bunch of other things that are not in Orleans. Around distributed cluster sharding and streaming and these things. We do not have transactions though, but through Cloudstate you can get them in through our state models in one way. We're working on CRUD support, key value support that will probably make that even more familiar now in a way. But it doesn't provide that explicit transaction model that Orleans has.